We have talked about the probability of equally likely events and also compound events. And now we're going to focus on events where we have some additional conditions or another event that's going to affect the calculations for our event. So in 7.4, we're talking about conditional probability. Example of a conditional probability might be something like guessing answers on a multiple choice test. So if there are 4 choices, the probability that I guess the correct one would be 1 out of 4. But if I add some additional condition that maybe I know for sure that one of the answers is not correct, then that's going to change the probability that I guess the correct answer. So if I am finding the probability that I guess the correct answer, given that I know one of the answers is incorrect. The notation that we use for conditional probability, we would use our P for probability of one event happening, and then we have this bar that we would read as given, and then we've got that other situation. So this would say the probability of A given B. Formula that we can use to calculate a conditional probability takes the probability of A intersect B, so both things happening, divided by the probability of B happening. Many of the probabilities that we encounter in daily life are conditional probabilities. So something like the probability of you going to college is 70% if your parents went to college, or relating to some of your majors, maybe what is the probability that someone becomes homeless given that they have a history of substance abuse? Or what's the probability that a suspect is guilty given that their fingerprints were found at the crime scene? What's the probability that someone studies music if they also play a sport? Those kind of things. So what's the probability of one thing happening given that something else has happened? Okay, let's look at some examples here. In this example, we've got a professor teaching 2 sections of philosophy, a regular section and an honors section, giving both of them the same test. Tell us how many students made A, and we're trying to see if he chooses a test paper at random, what's the probability that it's an A paper? And then in the second part, they give us an extra condition that we're choosing from the honors section. The probability that we are choosing an A paper out of all of the papers, here we've got a total of 35 plus 25 would be 60 students. And out of those, 14 students made an. So the probability that we choose an A paper is 14 out of 60. So the students that made an A out of the total number of students who took the test. Okay, now in part B, we've got an extra condition that we know the paper came from the honors section. So here we're finding the probability that we choose an A paper, given that we're choosing from the honors section. Okay, so I'm using this formula and in a situation where the events are equally likely, this is equivalent to using the number of items in the intersection over the number of items in B. And for us, the intersection is the students who had an A paper who are also in the honor section. So they both made an A and they're in the honor section. And the question here tells us that that was 9 students. And then we need to divide that by the total number of students in the honors section. So the question says the honors section has 25 students. So 25 in our denominator. So the probability that we pick an A paper from the honors section is 9 out of 25. In the second example, 2 cards are drawn from a bridge deck without replacement. So we're taking the cards out, we are not putting them back. What is the probability that the first card is an ace and the second card is a king. So here we're looking for the probability that two things are happening at the same time. So this is going to be a situation where we got to use our multiplication rule. So we want the probability that we choose an ace, and then we're going to multiply it by the probability that we choose a king, given that we have already chosen an ace. So that's going to look like, first let me kind of write it out as an equation. We're looking for the probability that we choose an ace first and a king second. So this is the intersection of these two probabilities. And calculating that, we just need to take the probability of the ace first and multiply it by the probability of king second, given we chose the ace first. So we're multiplying here. Okay, so just to kind of give it an equation visual to relate it to our formulas and what we're doing here. Okay, so the probability of choosing ace first, and in this deck of cards, there's 52 cards in the deck, and we're choosing one card. What's the probability that it's an ace? So in the deck of cards, there's an ace of each suit. So there's 4 aces in this deck with 52 cards. So the probability of choosing an ace is 4 out of 52. All right, so for the second probability, we didn't put the first card back. So now we only have 51 cards in the deck. So our sample space has changed to just 51 cards. And we're picking a card out of the 51, and we're assuming that the first card was an ace. So that would mean there's still 4 kings in this deck. So we have 4 chances to choose a king out of the 51 cards that are left in the deck. All right, so we'll just multiply these. It's going to give us 16 over, let me reduce it from here. Okay, so that amounts to 4 out of 663. That's the probability of choosing an ace first and then a king second. We're choosing 2 cards out of the deck without putting the first one back.